Good evening, students. How are you? This is Ankit Joshi. I welcome you all to India's largest live learning platform, Gradeup. I hope you are all doing fine. So today we are going to discuss a very important topic of linear algebra, engineering maths, that is Cayley Hamilton Theorem. Aman, Shweta, Sirisha, good evening all. Vivek, good evening. So I'll enter into this session now. I hope you are all doing fine. Hello everybody. I welcome you all to this session. So this is about me. I am Ankit Joshi. I have been teaching in this domain for more than 15 years. My subjects of interest are engineering mathematics, analog circuits, and signals and systems. So any of you or your friend wishes to join Gradeup platform, they can take the Gradeup subscription, and of course they can make use of my code joshi20. So this is my code. If you use this code, then you will be getting a 20% discount in the subscription. So these are the batches. Any branch can see this video, and you are all welcome to the session. Yes, Vijay Kumar, Lilesh, Vignesh, everybody welcome to the session. Basha Bhai, how are you? Namrata Mohanty, good evening beta, how are you? So these are the batches currently going on. Gear up batch, rank up batch, vision batch. The first class is going to start tomorrow. So any of you can join these batches. For any other queries, you can call at the number given below. On the top, yes, on the bottom right corner of the screen, 96500529904. So these will be the faculties who will be dealing with EAC, EC batches. Along with me, we have Rakesh sir, Sanjay Rathi sir, MN Ramesh sir, Chandan Jha sir, and Chaitanya Reddy sir. So let us start today's session. Today's session is about Cayley Hamilton Theorem. So this is a very important topic of linear algebra. And almost every year in all the branches, we are having questions in GATE exam and sometimes in EAC also. Okay. So this topic is really very important. And this is associated with eigenvalues and eigenvectors. This topic is associated with eigenvalues and eigenvectors. I request all of you to hit the like button. Hit the like button, share the link. Yes. What is the statement of this theorem? This theorem states that every square matrix satisfies its own characteristic equation. It means this is very clear that this is very apparent that this theorem is valid only for the square matrix. So if you are having a square matrix, then its characteristic equation will be satisfied by the matrix. That is the meaning. So we are having this matrix 1 2 3 2. यहाँ से शुरुआत करते हैं. Just taking an example. So if I write the characteristic equation, the format will be a minus lambda I determinant equal to 0. So how to write the characteristic equation? Just you need to subtract lambda from the diagonal elements, remaining elements as it is. Simplify this. You will get 1 minus lambda into 2 minus lambda minus 3 into 2, that will be 6. What I am doing? I am determining the characteristic equation of this matrix. Okay, so lambda square. I need your responses. Minus 2 lambda minus lambda will be minus 3 lambda, plus 2 minus 6 will be minus 4. So this is the characteristic equation. If you solve this, you will be getting some values of lambda. These values will be minus 1 and 4. And this is the characteristic equation. Let us say this is our equation number 1. We assume that this is our equation number 1. Now, what is Cayley Hamilton Theorem? Cayley Hamilton Theorem says that every square matrix satisfies its own characteristic equation. Every square matrix satisfies its own characteristic equation. Means what? What is the matrix given in the problem? अरे बच्चा कौन सा मैट्रिक्स सवाल में दिया हुआ है? They have given us matrix A. So according to this theorem, this matrix A satisfies its own characteristic equation. This matrix A will be satisfying its own characteristic equation. तो characteristic equation क्या है? Characteristic equation है equation number 1. So in this equation number 1, lambda can be replaced by matrix A. According to Cayley Hamilton theorem, lambda can be replaced by A. So by Cayley Hamilton theorem, put lambda equal to A in equation number 1. Okay, so you will get A square minus 3A. lambda square की जगह A रखा तो A square हो जाएगा. 3 lambda will become 3A minus 4. But in matrix equation we don't write constant alone. हम matrix equation में constant को अकेले नहीं छोड़ते हैं. We always multiply it by 1, and 1 is represented by unit matrix in matrix form. So 4i equal to 0. 0 will be a null matrix. Now all of you respond whether you understood this or not. बच्चा आपका response चाहिए. I need your response. What is Cayley Hamilton theorem? Cayley Hamilton theorem says that every square matrix will be satisfying its own characteristic equation. So I have determined the characteristic equation of this matrix. ये आपके लिए कोई बड़ी बात नहीं है किसी मैट्रिक्स का कैरेक्टरिस्टिक इक्वेशन निकालना. You can easily find out the characteristic equation. This is the basic concept already discussed in previous classes. Okay, so you have determined the characteristic equation. We have determined this characteristic equation as lambda square minus 3 lambda minus 4 equal to 0. Now in this characteristic equation, we want to apply Cayley Hamilton theorem. How I can apply Cayley Hamilton theorem? To this matrix? See here, what is the statement of Cayley Hamilton theorem? Cayley Hamilton theorem states that every square matrix satisfies its own characteristic equation. हिंदी में कहेंगे हर एक स्क्वायर मैट्रिक्स अपने ही कैरेक्टरिस्टिक इक्वेशन को सेटिस्फाई करता है. तो इसका एप्लीकेशन क्या, इसका मीनिंग क्या हुआ? इट मींस इन द कैरेक्टरिस्टिक इक्वेशन, व्हाट इज द वेरिएबल हियर? इन द कैरेक्टरिस्टिक इक्वेशन व्हाट इज द वेरिएबल? कैरेक्टरिस्टिक इक्वेशन में वेरिएबल कौन है? Who is the variable in characteristic equation? In the characteristic equation, variable is lambda. So we can replace lambda by the square matrix A. That is called as characteristic equation. Okay, Vinayak, moderator will be answering your query. Some moderator will be answering your query, Vinayak. Wait. Okay, yes. And stay tuned along with me in this session. So this is the application. This is how I applied the Cayley Hamilton theorem. I replaced lambda by A in the characteristic equation, and I got equation number 2. After getting equation number 2, Cayley Hamilton theorem is applied. Cayley Hamilton theorem apply हो गया. What are the advantages of this theorem? इस theorem के advantages क्या हैं? Okay, so just go to the next frame. A square minus 3A minus 4I equal to 0. This was our equation when we applied the Cayley Hamilton theorem. ये वो equation था जो हमें Cayley Hamilton theorem apply करने के बाद मिला. Okay, now if you multiply by A inverse in the entire equation, what I want to do? I want to calculate A inverse. So what you have to do? Multiply by A inverse throughout the equation. ये पहला application है. This is the first application. Yes, multiply by A inverse both sides. फरीद भाई थोड़ा पेशेंस रखिए, बहुत सारे काम की चीजें आपको देखने को मिलेगी यहाँ पर. Just have patience and enjoy this session. Multiply by A inverse in equation 1. So A inverse into A square will be A. 3 times A inverse into A will be I. Minus 4I into A inverse will be A inverse. So 4A inverse will be A minus 3I. All of you following? Hit the like button. Requesting all of you to hit the like button. So this is how we can calculate A inverse using Cayley Hamilton theorem. Cayley Hamilton theorem की मदद से A inverse कैसे निकालना है उसका रिप्रेजेंटेशन आपके सामने. Is that clear? What you have done in this equation, we just multiplied by A inverse. We just multiplied by A inverse throughout the equation. So we have got a term A inverse in our equation, and just we solved for A inverse, we got this format. Okay. Now finally what you have to do, you have to put the matrix A and unit matrix I and calculate this equation on the right hand side. You will be getting A inverse. Now another important thing that we can target here is calculation of A square, A cube, A raised to 4 and so on. So these are the other equations. These are the other quantities that we can target. So from this equation 1, देखो बच्चा मजा आएगा आपको. You will enjoy now. Find out A square. So what you need? A cube. अगर आपको A cube निकालना है, so A cube will be A into A square. That is A into 4I plus 3A. So A cube will be 4A plus 3A square. 3A square. और A square कितना है? How much is this A square? Vinayak, moderator will be answering your queries regarding. If you have any query other than what is the topic going on, your queries will be answered by moderator, not me. Okay, so please concentrate on what is going on. So A cube is 4A plus 3A square. A square is 4I plus 3A. So 4A plus how much? 9A. 4A plus 9A will be 13A plus 12I. So this is A cube. And similarly, we can further calculate A raised to 4. A raised to 4 is A into A cube. Have patience. I will be showing you some miracles. Just wait. A cube कितना है भाई? 13A plus 12y. So 13A square plus 12A. 13A square plus 12A. Now I am expecting A square from your side. What is A square? A square is 4I plus 3A. So 13 times 4I plus 3A. And this is 12A. So finally बच्चों हमें मिला 52I plus one more term was there. How much it is? 13 fours are 52. 13 into 3 39. 39 plus 12 51A. So I need your concentration. देखो बच्चा, by using Cayley Hamilton theorem I can calculate A square, A cube, A raised to 4 and so on. Easy. But the thing is, in order to calculate higher powers of A, suppose I want to calculate A raised to 50. Then I keep on calculating this, I keep on doing this. That will be a very lengthy approach. Are you getting my point? So Cayley Hamilton theorem's conventional method will not help you in GATE exam. So if a raised to 50 is asked, then this calculation will become very, very lengthy. Agreed or not? Do you agree with this or not? So this method is useful. This is conventional method of Cayley Hamilton theorem. So conventional Cayley Hamilton theorem can be applied only when you need smaller powers of a. But if you need higher powers of a, then this method seems lengthy. ये मेथड बहुत बड़ी हो जाती है. Are you getting my point? So I will be giving you a mastermind concept, a superb concept now to eliminate all these lengthy calculations. Do you want to see those? Do you want to learn those shortcuts? So now I will be going to give you a superb concept, a mastermind concept, so that easily we can calculate even higher powers of a by doing minimum calculations. So do you all support me? So I will be starting that smaller part, smaller calculations for you. See here. What you have to find? Sir, we have to find, suppose a raised to 4. Or suppose you need to find a raised to 50. So whatever you need to find, आपको जो भी find करना है, whatever you need to find, just denote it by f of a. उसको आप f of a से denote कर लीजिए. Whatever, thanks a lot all of you. Hit the like button. So whatever you need to find, just denote it by f of a. Then replace a by lambda. Mohammad Farid, देखो बच्चा, by Cayley Hamilton theorem you replaced lambda by a. So by Cayley Hamilton theorem I can replace a by lambda. चलो पीछे देखो, पीछे देखो. Go back. See here, see this equation. All of you see this equation. Thanks a lot, Sajal Rastogi. देखो बच्चा, A inverse. This is represented in terms of I and A. I want you to have a keen observation on what I am saying, what I am explaining. A inverse is expressed in terms of I and A. A square, देखो A square देखिए, see this A square. A square is mentioned in terms of I and A. A cube is also expressed in terms of I and A. A raised to 4 is also expressed in terms of I and A. So I can say that if A is a 2 cross 2 matrix, then any function of A can be expressed as the linear combination of I and A. अगर A कोई 2 cross 2 मैट्रिक्स है, तो इस A से बने किसी भी फंक्शन को हम I और A के फॉर्म में रिप्रेजेंट कर सकते हैं. ओके, आर यू फॉलोइंग? If A is a 2 cross 2 matrix, then any function of matrix A can be represented as the combination of I and A, where alpha naught and alpha 1 are some constants. Is that clear? This concept we have to use. So here A raised to 50. A raised to 50. A is a 2 cross 2 matrix. So bacha, this can be written as the combination of I and A. This is my equation 1. Now, by Cayley Hamilton theorem, you can replace A by lambda. Cayley Hamilton theorem की मदद से आप A को lambda से replace कर सकते हैं. So you can do this on the right hand side also. Replace a by lambda on the right hand side also. Replace a by lambda on the right hand side also. So alpha naught, I will be 1. In lambda form, I will become 1. Alpha 1 into a, that is alpha 1 into lambda. Now, this equation number 2 is true for eigenvalues of a. Equation number 2 is true for eigenvalues of a. इक्वेशन नंबर 2 जो लैम्डा के फॉर्म में आपको दिख रहा है, ये इक्वेशन आइगन वैल्यूज के लिए ट्रू होगा. सो लेट मी टेल यू let me show you what are the eigen values of a. So for this matrix, what are the eigen values? -1 and 4. इस मैट्रिक्स की आइगन वैल्यूज क्या है बताइए, फाइंड आउट. सर, सॉल्यूशन ऑफ द कैरेक्टरिस्टिक इक्वेशन आर द आइगन वैल्यूज. तो क्या है आइगन वैल्यूज? टेल मी. सर, आइगन वैल्यूज ऑब्टेन्ड एज -1 and 4. So this equation number 2 will be satisfying the eigen values. So what is the first eigen value? बोलो बच्चा, पहला eigen value क्या है? -1. So put lambda equal to -1 in equation number 2. Put lambda equal to -1. So equation 2, -1 raised to 50 alpha naught minus alpha 1. So -1 की पावर 50 कितना होगा? -1 to the power 50. How much will you get? You will get 1. Now another eigenvalue, lambda equal to 4. So put lambda equal to 4 in equation number 2. So equation number 2 implies that 4 to the power 50. No need to calculate 4 raised to 50. देखो बच्चा, 4 raised to 50 बहुत बड़ी वैल्यू होगी. नो नीड टू कैलकुलेट, कीप इट एज इट इज. इसको ऐसा ही रख लीजिए, कीप इट एज इट इज. Now see here, you have two equations in terms of alpha naught and alpha 1. अल्फा नॉट और अल्फा 1 की टर्म्स में आपके पास दो इक्वेशंस आए हैं. सॉल्विंग इक्वेशन 3 and 4. चलिए देखते हैं. सो व्हाट आई विल डू इक्वेशन 4 माइनस इक्वेशन 3. सो अल्फा नॉट माइनस अल्फा नॉट कैंसल. 4 alpha 1 minus alpha 1 will become 5 alpha 1. 4 raised to 50 minus 1. So alpha 1 will be 4 raised to 50 minus 1 upon 5. I hope you all have understood this alpha 1. मैं उम्मीद करता हूं आपको alpha 1 का वैल्यू समझ में आया होगा. Now after getting the value of alpha 1, I need to get alpha naught. मुझे alpha naught भी चाहिए. So from equation number 3, alpha naught is 1 plus alpha 1. I need your responses. मुझे आपकी मदद चाहिए. 1 plus alpha 1. 1 plus 4 raised to 50 minus 1 upon 5. So this will be 4 raised to 50. Taking the LCM, 5 minus 1 will be 4. So we have got alpha 1, alpha naught also. Yes. So alpha naught and alpha 1. I am having both these values. Now see this equation number 1. Equation number 1 is alpha naught I plus alpha 1 A. a raised to 50 is alpha naught I plus alpha 1 a. You have the value of alpha naught and alpha 1, put in equation 1. So a raised to 50 will be alpha naught I. What is alpha naught? 4 raised to 50 plus 4 upon 5. This is alpha naught. Alpha naught into I कितना है? 1001 plus alpha 1 into a. What is alpha 1? Alpha 1 is this one, 4 raised to 50 minus 1 upon 5. Are you getting? समझ में आ रहा है? Into a, alpha naught I plus alpha 1 a. What is a? 1, 2, 3, 2. I hope now you can simplify this to find a raised to 50. So 4 raised to 50 plus 4, 1 by 5 is out. 0, 0, 4 raised to 50 plus 4. Initially the calculation appeared difficult, but it is ultimately easier only. So 1 by 5 is out, 4 raised to 50 minus 1 into 1, then 2 times, then 3 times the same term, and then again 2 times the same term. Now finally you have to add these two matrices. कर सकते हैं एडिशन? कर लेंगे या मुझे करना होगा? नहीं सर आप ही कर दो. So addition of these two, 4 raised to 50 and 4 raised to 50. 2 times 4 raised to 50. 4 minus 1, 3. Then 4 raised to 50 and 2 times 4 raised to 50. 3 times 4 raised to 50. 4 minus 2 will be 2. Then, wrong. Addition, See, this term with this term. Okay, 0 plus this term will be as it is. Sorry for this. Then 0 plus this term. Same. 4 raised to 50 minus 3. Then 4 raised to 50 plus 4. And 2 times 4 raised to 50 minus 1. So 4 raised to 50 and 2 times 4 raised to 50 will be 3 times 4 raised to 50. Then 4 minus 2 will be 2. I hope you would have understood the calculation of a raised to 50. Do you enjoy this calculation? Have you enjoyed this calculation? So ultimately with the help of Cayley Hamilton theorem, we can calculate higher powers also. But if you use the conventional approach, then it will be difficult for you to solve. It will be lengthy process. But if you have this approach, ये approach है आपके पास, alpha naught and alpha 1 वाला, then you can easily find out a raised to 50. Hit the like button if you really like this approach. Nagurwali, last step is just the calculation. Take your time at home and take the screenshot and just do the calculation once again. Next, see here, कुछ key points है जो आपको समझना है. For a 2 cross 2 matrix, any function of A can be written as the linear combination of I and A. Okay, means this A is a 2 cross 2 matrix. Then I can write it as alpha naught I plus alpha 1 A. But if A is a 3 cross 3 matrix, if this A is a 3 cross 3 matrix, then right hand side will be expressed in terms of I, A and A square. I, A and A square. If A is a 3 cross 3 matrix, then right hand side will contain I, A and A square. And of course the constant terms involved will be alpha naught, alpha 1 and alpha 2. you will be having 3 equations. So solving 3 equations in gate examination is a lengthy process. That's why 3 cross 3 matrix will not be expected in gate examination. Okay, 2 cross 2 matrix easily you can solve and with less amount of time. That's why this method is useful for gate exam for 2 cross 2 matrix. To find higher powers, if you want to determine only the smaller powers, then conventional method is also good. Now suppose I want to solve the same to find a raised to 4. So what you want to find? Sir, we want to find f of a. F of a is a raised to 4 alpha naught I plus alpha 1 a. Okay. F of lambda will be lambda raised to 4 alpha naught plus alpha 1 into lambda. Equation 1, equation 2. Chaliye. Thank you Lalit bhai. Thank you bacha. Now see here. This equation number 2 is valid for eigenvalues. So what are the eigenvalues of this matrix? -1 and 4. चलिए लैम्डा इक्वल टू -1 रखिए इक्वेशन 2 में क्या मिलेगा 1 इक्वल टू अल्फा नॉट माइनस अल्फा 1 अल्फा नॉट माइनस अल्फा 1 इक्वल टू 1. ये पहला इक्वेशन. व्हाट इज द अदर इक्वेशन? पुट लैम्डा इक्वल टू 4 इन इक्वेशन 2. रख दीजिए इक्वेशन 2 में लैम्डा का वैल्यू 4. 4 रेज टू 4 256. Yes, thank you. Solving equation 3 and 4. Solving equation 3 and 4. So subtract 4 minus 3. So alpha naught cancel. 5 alpha 1 equal to 255. Alpha 1 equal to 51. If alpha 1 is 51, alpha naught will be 52. So a raised to 4 is alpha naught I plus alpha 1a. Directly, simply we can write it as 52i plus 51a. All of you followed this approach? And now you can put the value of I and a. What they want? They wanted a raised to 4 in terms of I and a. So this is the final answer. This is the final answer. We'll having a trademark of Ankit Joshi. Trademark of Gradeup as well. This method is really very revolutionary. This method is revolutionary when you are into the GATE exam or similar competitive exams. This will help you a lot. Shall I proceed? Next. Now this I am leaving for you. This particular part I am leaving for you. चलिए कर लेते हैं. A cube is alpha naught I plus alpha 1a. Lambda cube alpha naught plus alpha 1 into lambda. Now find out the eigenvalues for this matrix. -5 minus lambda, -3, 2 minus lambda. Solve this. You will be getting lambda square plus 5 lambda plus 6. So easily I can say that -2 and -3 are the eigenvalues. -2 and -3 are the eigenvalues. So put lambda equal to -2 and lambda equal to -3 in equation number 2. So what you will be getting? Alpha naught -2 alpha 1 -2 cube is -8. Alpha naught -3 alpha 1 सुधांशु जैन कौन सा इक्वेशन रॉन्ग है भाई? इक्वल टू -27. पिछले 15 साल से तो यही आ रहा है, अभी कुछ बदल जाए तो पता नहीं. So Subtract these two, alpha naught cancel. Then minus 2 alpha 1 plus 3 alpha 1. Equation 3 minus equation 4. So alpha 1 will be minus 8 plus 27. 19. Alpha naught. कोई दिक्कत नहीं बच्चा, कोई दिक्कत नहीं. गलतियां होती है, हमसे भी कई बार होती है, मजाक किया था मैंने. अल्फा नॉट, अल्फा 1 is 19, 19 2s are 38, minus 8 plus 38 will be 30. So a cube will be alpha naught I plus alpha 1 a. देखो बच्चा कौन सा ऑप्शन है, ढूंढो, सर्च फॉर द करेक्ट ऑप्शन. 30i plus 19a, 30i plus 19a, ऑप्शन बी इज द करेक्ट आंसर. चलिए आगे चलते हैं. टेक द स्क्रीनशॉट, हिट द लाइक बटन, विल मूव अहेड. I want to inform you that I have got a dislike on this session as well. I have got a dislike on this session. Great. If you are really enjoying it, hit the like button. Now see here. A raised to 50, we'll do it later. A cube. This is for you. Nishant, bacha, you can watch the recorded lectures. Now, write the characteristic equation. Minus lambda 1 minus 1 minus 2 minus lambda. नहीं धोखेबाज नहीं है वो, हमारे लिए धोखेबाज नहीं है ऐसा बच्चा जो डिसलाइक कर रहा है. वो अपने साथ खुद के साथ छल कर रहा है या मूर्ख है, उसको अच्छे बुरे में समझ ही नहीं. खैर सोशल मीडिया पे सब कुछ वेलकम है. चलिए, सो माइनस लैम्डा, माइनस 2 माइनस लैम्डा 1 माइनस 1. चलिए, सो लैम्डा इंटू 2 प्लस लैम्डा. Sometimes they are teachers only, teachers on other platforms. क्या कर सकते हैं. अब मेरी फ्रेटर्निटी के बारे में, मेरे भाइयों के बारे में मैं क्या बोलूं, सब अच्छा है. ऑल आर वेलकम, ऑल आर वेलकम. अगर एक भी बच्चे को फायदा हो जाए मेरे सेशन से तो मेरा पढ़ाना ठीक ठाक रहेगा, सफल हो जाएगा. सो फाइंड आउट a raised to 50, a क्यूब. चलो फाइंड करते हैं. कंपटीशन बराबरी वाले से होता है, अपने से बड़े के का पीछा किया जाता है, चेज किया जाता है ना, और वो चेज हमेशा चेज ही रहता है. चलिए, a raised to 50, अल्फा नॉट I, अल्फा 1 into a, लैम्डा raised to 50, चलिए, व्हाट आर द आइगन वैल्यूज. सर -1 एंड -1. थैंक यू, दैट इज अवर एम. lambda raised to 50 is alpha naught plus alpha 1 lambda. Lambda is -1. Lambda is -1. Please concentrate in this question. What is the problem with this question? What is the problem with this question? What is the problem with this question? Tell me. When you put lambda equal to -1, You will get the equation. Now, एक इक्वेशन मिल गया आपको. We have got one equation. Now, how to get the second equation? अरे eigenvalues are same. Eigenvalues are same. How to get the second equation? अब आप मेरी आंखों में देखिए. सुधांशु बेटा निकालेंगे निकालेंगे. We will find out. I have once again I am having a superb concept now. Once again I am having a mastermind concept, superb concept ahead. Do you want to hear? आप जानना चाहते हैं क्या वो concept? बॉक्स को अनबॉक्स करना चाहते हैं क्या? Still we can find out alpha naught and alpha 1. With your permission and with no sense of arrogance, I want to tell you that we can find out alpha naught and alpha 1 still. Now, whenever, listen carefully, whenever eigenvalues are repeated, whenever eigenvalues are repeated, whenever eigenvalues are repeated, see here, apply once the eigenvalue, so you will get one equation. Second equation is missing. Second equation is missing. How to get the second equation? How to get the second equation? देखो बच्चा, what is your equation number 2? Equation number 2 is lambda raised to 50 I am giving you a thumb rule. Whenever eigenvalues are repeated, you can differentiate equation number 2. You can differentiate equation number 2. So differentiate with respect to lambda. So 50 times lambda raised to 49. So alpha 1 will be 50 times lambda raised to 49. Now, in this relation, put the value of lambda minus 1. But this step will be applicable. This step will be applicable only when eigenvalues are repeated. Bajao tali, enjoy this concept. This step will be applicable only when eigenvalues are repeated. This differentiation step is applicable only when eigenvalues are repeated. See here. आग लगा दी आग. मेरे बच्चों ने आग लगा दी है कंसेप्ट में. मेरे स्टूडेंट्स के लिए कुछ भी कठिन नहीं है. Everything is easy for them. And this concept I have got derived from complex variables. एक चैप्टर है इंजीनियरिंग मैथ्स में complex variable. From the concept of singular points, from the concept of singular point analytic functions in complex number, I got derived this concept. This differentiation is allowed only when, yes, this differentiation is allowed only when the eigenvalues are repeated. Otherwise, you cannot apply. Vijay Kumar, if it is a 3 cross 3 matrix, then on your right hand side there will be 3 terms, alpha naught, alpha 1 and alpha 2. If all the 3 eigenvalues are repeated, then you have to differentiate twice. Yes, we have got the value of alpha naught and alpha 1. So alpha naught is minus 49, alpha 1 is minus 50. So a raised to 50 is alpha naught, that is minus 49 I. सुधांशु जैन, समझ में आया बेटा ये? You just verify whether I have done the calculations correct or not. That's it. So this is the answer. क्लियर? चलिए ए क्यूब निकालते हैं. ए क्यूब सी हियर. पहले आगे चलते हैं. लैम्डा स्क्वायर प्लस 2 लैम्डा प्लस 1 इक्वल टू 0. कन्वेंशनल मेथड से ए क्यूब निकालते हैं. Let us calculate a cube by conventional method. So a square plus 2a plus I equal to 0. A square will be minus I minus 2a. Then a cube will be minus a and minus 2a square. A cube will be माइनस ए माइनस 2a स्क्वायर. और a स्क्वायर कितना है? a स्क्वायर इज माइनस ए माइनस आई माइनस 2a. सृष्टि गुप्ता, थैंक यू बेटा. प्लस 2i. एक बार चेक करो बेटा इसको. 2i माइनस ए और माइनस माइनस प्लस 4a कितना होता है? ये माइनस एंड माइनस प्लस 4a. 4a माइनस ए इज 3a. देखो बेटा सुधांशु, ये कन्वेंशनल मेथड से हमने ए क्यूब निकाल दिया. अब मैं वेरीफाई कर देता हूं कि मेरा जो कॉन्सेप्ट है वो सही है या नहीं. ए क्यूब निकालना है बाय अवर मेथड अल्फा नॉट अल्फा 1 मेथड. सो ए इज ए 2 क्रॉस 2 मैट्रिक्स. ए इज ए 2 क्रॉस 2 मैट्रिक्स. सो ए क्यूब कैन बी रिटन एज अल्फा नॉट आई प्लस अल्फा 1 ए. ठीक है सर. सो लैम्डा क्यूब विल बी अल्फा नॉट प्लस alpha 1 into lambda. Okay sir, equation 2, equation 1. So I am doing the same thing by some other method. That is our new method. So put lambda equal to minus 1, where minus 1 is the eigenvalue. So equation 2 will imply alpha naught minus alpha 1 equal to minus 1. Equation number 3. Differentiate equation 2. So 3 lambda square equal to alpha 1. Put lambda equal to minus 1. So when you put lambda equal to minus 1, alpha 1 equal to 3. Alpha 1 3 है. Alpha 1 is 3. So alpha naught will be minus 1 plus 3. That is 2. See here, alpha naught is 2, alpha 1 is 3. A cube alpha naught I plus alpha 1 a. कंपेयर द बोथ द रिजल्ट्स. दोनों रिजल्ट्स कंपेयर कर लो. कंपेयर बोथ द रिजल्ट्स. रिजल्ट ऑब्टेन्ड बाय अल्फा नॉट अल्फा 1 मेथड एंड रिजल्ट ऑब्टेन्ड बाय कन्वेंशनल मेथड. क्या ये दोनों रिजल्ट सेम है? आर बोथ ऑफ दिस रिजल्ट सेम? इफ यस, देन आई कैन टेल दैट, आई कैन से यू दैट दिस डिफरेंशिएशन कॉन्सेप्ट इज ऑलवेज ट्रू. सृष्टि, रेवन्ना, सुधांशु, विजय कुमार, पवन, नगुरवली, सौम्यजीत, लीलेश, विवेक गोस्वामी, everybody, have you realized whether this method is all perfect? So without hesitation, when eigenvalues are repeated, you can differentiate and form the second equation. जब eigenvalues repeat होंगी तो हमको इक्वेशंस का शॉर्टफॉल होगा. जब आइगन वैल्यूज रिपीट होंगी तो हमको इक्वेशंस का शॉर्टफॉल होगा एंड वी कैन डिफरेंशिएट इक्वेशन नंबर 2 टू फॉर्म द अदर इक्वेशन. Yes. Thanks. We are moving to the next. I think this you can do now. Hello. Sai Baba. Thank you, beta. These eigenvalues are 3 and 3. Repeated. Eigenvalues are 3 and 3. So this is a cube. A cube is alpha naught I plus alpha 1 a. Find out the answer. Hit the like button, all of you. Hit the like button, share the link. Alpha naught I plus alpha 1 a. This is equation 2. So, eigenvalue is 3. Put lambda equal to 3 in equation 2. Alpha naught plus 3 alpha 1 equal to 3 cube, that is 27. So, again we are having repeated roots. We will be having only one equation. Srishti Gupta, thank you, beta. Now, what is this? How to find out the other equation? Other equation, roots are repeated. Differentiate equation 2. So, alpha 1 will be 3 lambda square. Put lambda equal to 3. Alpha 1 is 27. 27 into 3 is 81. 27 minus 81. Minus 54. Check करो जरा. ठीक है. So a cube will be minus 54i plus 27a. Just check it once. So within some 30 seconds or 40 seconds you will be able to solve this question. 30 seconds में question solve हो जाएगा. So I have given you some very important tricks, shortcuts and some superb and mastermind concepts to solve this higher powers of A. Next. Sir, oh, I want to calculate a function sin A used from this matrix. इस मैट्रिक्स से मुझे sin A निकालना है. I want to find out sin A. Eigenvalues will be plus minus 3. यस गोस्वामी जी, करेक्ट है. चलिए इसके आइगन वैल्यूज निकालिए. सबसे पहले 2 minus lambda 5 1 minus 2 minus lambda. So lambda plus 2, lambda minus 2, lambda square minus 4 minus 5, lambda square minus 9. So lambda equal to plus minus 3. These are the eigenvalues. Plus 3 and minus 3. So this is f of a. Alpha naught I plus alpha 1 a. Then sin lambda alpha naught plus alpha 1 into lambda. Now this equation will be true. This equation will be true. Equation 2 will be true for eigenvalues 3 and minus 3. So put lambda equal to 3. Rakhiye. So alpha naught plus 3 alpha 1 equal to sin 3. Put lambda equal to minus 3. So alpha naught minus 3 alpha 1. चलिए जल्दी जल्दी कीजिए. Alpha naught minus 3 alpha 1 equal to sin lambda. Sin of minus 3 will be minus sin 3. चलिए बच्चा, ये दो इक्वेशन आपके पास है. You have these two equations. So equation 2 minus equation 4. Sorry, equation 3 minus equation 4. So alpha naught minus alpha naught cancel. 3 alpha 1 minus minus plus 3 alpha 1 will be 6 alpha 1. Sine 3 minus minus plus sine 3 will be 2 sine 3. So I can say that alpha 1 will be sine 3 by 3. Sir, find out alpha naught. Alpha naught भी निकालिए sir. Alpha naught will be sine 3 minus 3 alpha 1. Alpha 1 is sine 3 by 3. So alpha naught is 0. Alpha naught is 0. So what we want? We want sine A. So this sine A, alpha naught is 0. Alpha 1 is sine 3 by 3. This is the answer. ये आंसर है बच्चा, देखो. Are you enjoying? कंसेप्ट में मजा आया? Tomorrow, Sunday, 3 PM आफ्टरनून, वेक्टर कैलकुलस का मैराथन सेशन है 4 घंटे का. कल दोपहर 3 बजे से लेके 6:30-7 बजे तक वेक्टर कैलकुलस सिखाऊंगा. अगर अटेंड कर लिया तो वेक्टर कैलकुलस में कभी भी भविष्य में आपको दिक्कत नहीं होगी. Tomorrow is a marathon session on vector calculus at 3 PM. Marathon Sunday with Ankit Joshi, 3 PM afternoon. Yes, Lilesh. Everything will be easy for you because you have the concepts now. आगे चलते हैं. एक दो क्वेश्चन होमवर्क दे रहा हूं मैं आपको. हिट द लाइक बटन ऑल ऑफ यू. जो ऑनलाइन है, जिन्होंने लाइक बटन हिट नहीं किया है, लाइक बटन को हिट कीजिए. चलिए, सी दिस. दिस इज द Gradeup green card. So there are many advantages of this green card. You can have online mock test. You can have, yes, various structured live courses, doubt clearing sessions, full coverage of the syllabus. So you can subscribe for this green card and you can use my code joshi20 for the subscription so that you will be getting a 20% discount. I am informing you that tomorrow 3 PM CSE वाले बच्चों को वेक्टर कैलकुलस सिलेबस में नहीं है, गेट के सिलेबस में. अपार्ट फ्रॉम CSE, अपार्ट फ्रॉम कंप्यूटर साइंस, ऑल अदर ब्रांचेस कैन अटेंड दिस. Thanks a lot. And just take this. So leave it. These are all gate questions. Leave it. I'm having a quiz question for you. Quiz. This is the quiz for you. So you have to solve this question and yes, you have to comment in the comment box. Thanks a lot. May God bless you all. Take care of yourself and take care of your parents as well. Take the screenshot of this question. So these are our toppers. I want you to be here in the upcoming result. Thanks a lot. EAC and GATE Gradeup achievers. Oh my God. All India rank 1, 10, 27, 4, 6, 9, 9, 20, 25. Great. These are not the marks. These are the All India ranks. So just you can have the screenshot and answer in the comment box. Thanks a lot. Bye-bye. We'll meet tomorrow in Vector Calculus Marathon. Yes, I am feeling good. Thanks a lot for the concern. We'll meet tomorrow. Bye-bye. Have a nice day. Take care of yourself and your parents as well.